Hi James. I'm still working on problem 21. There were some graphing parts in it that we had to go over, and I wanted to show you. First was with respect to part C thereof, and that it says when is the ball at its maximum height, determine the maximum height of the ball. So how to do that? Well, first of all, we just go ahead and put in our equation. So it was negative 16t, but here we're just going to use x squared. And then let me see, plus 50t, and then plus 6. Notice I'm just plotting really the y part of the parametric equation. So, okay, to go ahead and do this, what's the best way to get it to graph so you'll know what you can see the relevant part? So I initially choose zoom fit just to see what we get. But you'll see in that parabola, most of our the parabola is in the underneath the x-axis is in sort of a negative x region, and obviously we don't want that region. We want to know, where the ball goes up and when it comes back down and hits the ground. So this line here represents the ground, and all this stuff that's happening sort of underneath the ground really is not relevant to us. So what I did to fix that is I went back to Zoom and I used Zoom Box, and I moved this up to a place where I thought it would be reasonable, where we could get most of it. So I have it a little bit below the ground, not much. And I think if I move it over to there and get the box sort of covering that region and redo it, we'll be able to see most of the parabola that we need to. And then we can just sort of make little adjustments in our window. So we can have let me see, y maybe going from more like, I don't know, maybe negative 10. It doesn't have to go down that far. And then we can have it go to 50. Actually, why don't we just make this 0? Or more like maybe just negative 5 maybe. Yeah, just let's make it just negative 5. So we just get a little bit so we can sort of see where the ground is. And for X max, pretty much we were set with that. Why don't we have this be maybe negative 1? And let me see. X max, it looks like maybe it ought to go over to about 5. That should be a pretty nice adjustment there. We can have those steps in 1. These steps for y, probably what we ought to have them, about 10, so it won't take up so much space. And then we'll go ahead and regraph it. And there we get it looking really nice, and we can determine where the maximum and minimum are. If you want to do it a little bit more, I guess you could maybe make x maximum 4. That might make it a little better and fill up the window a little bit more. So that is a fairly nice window. Okay, so let's go ahead and determine where the maximum is. And we should get it. Yeah, and there we get the maximum and the minimum, and these are the values we got. It's at t equals 1.56 when the 1.56 seconds when it's at the maximum. The maximum value that it reaches, or the maximum value up and down the y-axis, is going to be at 45.06. So those are the answers we were looking for. So I should go ahead and take a screenshot of this. And this will be problem 21, part 1. So we'll save that. Okay, the next thing I wanted to show you was the part for part D. It says simulate the motion of the ball by graphing the equations found in part A. So for this, let's go ahead and just reset the calculator. Okay, so for this we need to be careful about what mode we're in. We want to be in parametric mode. So we'll do that, and then we'll go to our Y and X windows. So our x part of the equation was just 0. It was x equals 0 because there is no motion in the x-axis. However, in order to see the ball going up and down, you really don't want it to go up and down the y-axis at x equals 0 because that's not going to enable you to see what's going on. So they recommended in your book that you make this maybe 3. And y is the one that we calculated. So that's going to be negative 16t squared plus 50t plus 6. And now we just need to sort of worry about the window. Oh, there is one other thing you have to be clear about, and this is actually important. They don't really tell you how to do this in your textbook, so in order to get it to show how things are being traced out, it might trace it one time and then follow along the same line again. You wouldn't be actually able to see how the full thing is, how the path is being traced out. So what you need to do is go over here, and then you just keep hitting enter until you get a little ball like there. So that's really important. That's an important step to take in this. So once you've done that, now you move on to the window. Okay, for the window, we're going from T min to T max. I think we have the ball hitting the ground at 3.24 seconds, so why don't we go ahead and just put in 3.24 here for T max. That should be the full range of the ball. The steps for T, I like having it move kind of slow, so I'm going to just go 0.05. I think they suggest 0.1 in your book, but I'll have it go a little bit slower than that. Okay, the steps x min, x max, as we noted before, it doesn't move along the x-axis, so we just need to make sure we can see what we've graphed. So we can have this be 0, and I think we have it going up and down at 3. So we'll set that at, let's go ahead and set it at 5. And do we really even need tick marks along the x-axis? Well, I guess we can or cannot have them, but we'll keep them at 1. All right, y min and y max. The maximum height the ball reaches, as we figured out before, was at 45.06 feet. So why don't we set that at, I don't know, 50 feet? Would that be good? I suppose we could do that. Yeah, why don't we go ahead and go 50 feet? Or we need y minimum, rather, to be 0, and y max to be 50. And then we think about the steps here, and if it goes from 0 to 50, you probably want it to go 5, about every step, about 5, I guess. And that should show it. The other thing you might want to do here, instead of making it 0, you might want to make it, I don't know, negative something, just so you can see the y-axis. Or the x-axis. I'll just make it -2. And now we'll go ahead and graph it. So you'll be able, because we took that step where we put the little circle when we were back in the graphing window here, since we have the little circle there, you'll be able to see the ball go up and come back down. And that's the important part that they wanted you to show. So we'll go ahead and do that. There it is going up, reaches its maximum height, and there it comes back down again. Now I'm having it move a lot slower than it ordinarily would. Why don't I go ahead, just to show that we've done this, why don't I go ahead and redraw that and take a screenshot somewhere midway along the way. So I'll just redraw it again. And there it goes. Let's take the screenshot about there. Or maybe we ought to go a little bit more. I don't know. Maybe when it's coming down. So we'll take our screenshot there. Actually, that doesn't look good. Take our screenshot there. And we'll make that the one for problem 21 part 2. In case you want to incorporate these into your homework when you turn it in. And that's it. And now notice, of course, as what you can do if you want to sort of speed it up. I had it at 0.05, but we can just make this 0.1 instead. Now it'll go quite a bit faster. About twice as fast, I guess. And you can also kind of see gravity working there too. You can see as it gets up near the top, it kind of slows down, and then as it starts to come down again, it comes down faster and faster as it gets lower and lower. Why don't we watch that one more time, and then okay, here we go. So you sort of slowing down. Now it's going a little bit faster, a little bit faster, a little bit faster, and that's it. Okay, so not too interesting, but that is the graph and how to do it to get the ball going up and down and going up and down a straight line, which is what this problem asked you to do.